If we want to look at the chart that will show us how various prices fall into ranges, a good chart is a histogram chart. The histogram chart looks a little bit like a bar chart because it's made out of rectangles, but it's different because instead of showing each bar represent one price, each bar represent a range of prices. And it can really help figuring out things that, for example, if we want to look at the stock or crypto and we want to try and figure out what is the price that most of the days of the years that price falls into, a histogram is ideal chart for that. What we're going to be doing in this section is we're going to put everything together. I'm going to show you how to work with D3 and React, and we're going to include integration with other component. So to do that, we're going to use a data management, Recoil, that will allow us to do all of that. We can share the same data between multiple components. So you can see here we have the histogram that shows us the days, it shows us the price, and then we have the numbers of ticks. The numbers of ticks meaning how many bars we want. We're going to let the user select how many bars, and once the user change the numbers of ticks, we're going to create interactivity, but this time we're going to do the animation of the transition by just changing the numbers of ticks, and that way we'll see the difference. So it's not going to fade out like in the last chart we created. It's actually going to change the result in a more elegant way when we change the number of ticks. On the right here, it shows us the day. So this is the first day of the year, second day of the year. So we can actually pick, for example, day number 150, and we can see the price that the crypto was at that day. So it kind of shows us really everything together, how to really work with D3 and React. We'll create a new project. So going to create React app template must have libraries, and we're gonna copy the command, and then in terminal just paste the command yarn create React app, and then let's call it histogram, and the template is must have libraries. So we can set up our project. While it's downloading, I want to show you something. If you go to the ethereumprice.org, it gives you historic price for Ethereum. So you can actually pick the date. I picked last year's date, 2020, and then you can download the CSV. So download the CSV, and then what we can do is we can use that CSV for data. Next, open the project in your favorite IDE. I'm using WebStorm, and then import the CSV file and rename it historical price. And if you open it, you can see it's made out of a few elements. It's made out of timestamp, open, high, low, and close. Really the only metrics we need is open, because it's downloading it per day. So each row represents one day in our chart. So we don't need the other fields. And if this was going into production and I don't need the other field, I would open the CSV in Excel or something and remove all the other column. So it's going to load faster, because you can see we got 362 days that I downloaded. But since we're just doing this to learn, I'm going to keep it as it is. In terms of the data, we're going to go and create a model file, a model object file. So create a new file, and let's call it historical price.typescript. And if you're coming from the world of Java, you know about the model object, and the idea is to kind of have a place that will hold our type. Now we are creating type for TypeScript, but because we're using a state management, we want to extract that, so our state mechanism is completely loosely coupled and not depending on some code that we write inside of a component. So it's just a better way to architect it, but it's not the only way. There's many other ways. So you can do whatever you think is right after you see how I'm doing that. What I'm doing is I'm creating an historical price object interface. Doesn't like it. It doesn't like it because it wants the H, my ESLint is set that the H needs to be uppercase, but I really want it this way, so I'm going to force that. And then I can export a constant that will initialize my object. So I can call it initialize historical price object, and then it's going to be of the type of our object. And what I can do is I can set, what happened here? I can set the price to be 0. This way I can just call this initialize historical price object, and I got a type of my object that it's already initialized with the value of 0. Then to access this neatly, I'm going to create an index.TypeScript file, and here I'm going to export everything for my historical price TypeScript. This way it's going to be easy to access that. Next, for data management, I'm going to be using Recoil. Recoil is still an experiment, but it's a game changer. If you use Redux, you probably know how much boilerplate code you need to do in order to share state. And there's other option. You can use the context. For example, instead of using state management, and there's many other libraries, but Recoil is really a game changer because it feels as if you're still using React versus other library that you just have to put a lot of boilerplate code. And it's such a game changer, and it's so easy to use. And if you want to understand better about Recoil, read the ebook that is attached with this section of the course, and it gives you much more information about Flux and how Facebook came to work with Recoil. What we're going to do, we're just going to start using it, and you're going to see how intuitive and how straightforward it is to work with it. So the first thing we need to do is we already have a Recoil folder, and Recoil is already installed as part of the library of the template that we created. So must-have libraries template of create React app already include Recoil. So if you look at the package JSON file, you'll see it's using Recoil, and the ESLint is already configured. Everything is configured. You can just start using it. So as you can see here, we have a Recoil folder, and inside we have two folders. We have atoms and selectors. And Recoil is really about those two things, atoms and selectors. And you don't even need to use both of them. You can just use an atom without a selector and share your state, just like you do with the use state, or you can use both of them. We're going to start from the selector. If you open up the selector folder, you could already see that I have an example there for you, and a link to an article how to work with selectors and atoms. To work with it, we're just going to create a new file, and let's match it to our CSV. So let's call it historical price selectors. I'm using selectors and not selector because you can actually put several selectors at once in each one of them. So just a good practice to do that. And what we're going to do here is we're going to retrieve our data. So in terms of Recoil, we need to do this. We need to create our function, and let's call it get historical price data. So it's intuitive, and we're going to use the selector from Recoil, and inside of our selector, let's see, it doesn't let me import it. We're gonna have to do it manually. Import Sometimes the auto suggestion doesn't work in WebStorm. So import selector from Recoil. Okay, here we go. And inside of our function, we need to set two things. We need the key, and we need a get method. So our key, the common practice with the Recoil is to use a capital letter of the same methods. And then in the get, we're going to create an asynchronous method that will go and pull our data. And we can actually, instead of putting it in line, it's better to split it for code readability. And then we can create another method to actually get the data. And if you don't have the data, for example, you can actually parse here an array or an object if you don't have it connected yet. So it's good for cases that you want to work with dummy data. What we're going to do is we're going to create a promise, and we need to pass the resolve in a promise of what we're going to give back. So our promise is going to return us. We're just going to use what we did before, which was the D3. And before we use D3, we need to make sure it's installed. So in terminal, just type in yarn add D3 and types D3. That's going to install that for us. And then in terms of the method, we're just going to use the DSV because our type is CSV. So D3 DSV, and we have to import, no suggestions. So let's import it manually. Import everything from as D3 from D3. And now, let me make sure it works. Okay, now we need to pass a few things. We need to put the delimiter, which was a comma on a CSV, and then we need to put our file, which was data slash, let's see, if you go here, public data historical price CSV, so put that in. And then the next thing we need is we need to handle the function once the data is returned. So do function, and we need to pass the results as a data, and we can on the return we can actually set it. If you remember, we're going to use the open price as our price. So we'll set the price as d.open. That's going to format it to use the price as the open price. And then we need to put a then function. So after the data is returned, we're going to create a function that has the results, and we're going to resolve that back to whoever calls this. So we're going to resolve data as, we need to parse it as unknown because it's not going to know what type it's going to come as, and parse it as the historical price data object. That's it. So now if you look at the code, what's really happening is once we call the historical price data selector, it's going to do an asynchronous call to get our data, and we're going to use a promise to resolve the data results, which will format our historical price CSV as price. So it's going to take the d.open. So if you look back at our data, it's gonna take that data and format it as dopen. The next thing we need to do is we need to create our atom. If you go to the Recoil folder, you see we have an atom folder, atoms, and inside I left you an example of how to work with it. So you can use that example, or write the code yourself. So what we can do is we can create a new file, and let's call it historical price atoms. And again, you can put several atoms together, so that's why I'm giving it the name of atoms and not atom. And here it's really similar to selector. We need to set our function, which is going to be historical price. We can call it state, and then set it of type atom, and it expect a key, and it expect a default value. So for the key, we're just gonna use the same name, historical price state. I'm just gonna put it capitalized. That's how it's common, that's the standard. Looks like it doesn't, the ID doesn't recognize atom, so let's import it ourselves. So it's import atom. We need to import it from Recoil. And then for the default state, what we can do is we can use the initialize historical price we created, and that's gonna use that default value that we set. Let's make one change. Instead of calling it initialize historic price, let's call it initialize historic price object, so it's matching our object. And let's make the change here and here. So it's called initialize historical price object. Okay, great. Now we have everything that we need in order to go and retrieve the data using Recoil. And the next step for us is really to create our component and our component widget. So if you remember, inside of the widget, I left you the command using the generate React CLI component. So inside of terminal, let's create a component. The widget component, we'll call it historical chart. No, I'm sorry, let's call it histogram chart. And for the widget, we'll call it histogram chart widget. So I'm just putting it in a new tab. Histogram chart widget and Instagram chart component. Takes a few seconds, so I'm running it in two separate tabs. Okay, now that we have the component ready, open up app.tsx and let's replace. If you look at the app right now, we have the default template running. So we're gonna get rid of all the tags inside of the header, and let's replace it with a widget. So we called it histogram chart widget. There you go. And we don't need the logo, we're not using that. Now inside the histogram, we need to make the changes. This is all should be, this is what we've done so far, so nothing should be new. So we need to set the histogram chart component and the chart helper, histogram chart helper. And we need to import that component Now if you, let's see that we got rid of all the errors. Okay, this is good. We're not going to pass any property, so we can clean up the property interface. And what we did before is we loaded our data right in our widget. And now that we have Recoil, we don't need all of that, so you can delete all that code because we're going to load it using Recoil. And we don't even need the use effect. So you can clean all that stuff up. To get the data, what we did before is we use a state and we got the data, but now we can use recoil. So what we're going to do is we're just going to create a new constant and let's call it data. And that's going to be of type historical price object. That's the model we created. And that's going to be an array object. And that's we're going to use, instead of use state, we're going to use recoil state. Actually, it's not recoil state, is we need to use recoil value to retrieve the value. And then instead of recoil value, we need to call the method that get historical price data that we set. That's our recoil selector. And then we need to cast it as historical price object array. And this code really replaced that data and the set data, and now it's gonna go and bring it from recoil instead of using the set state. Let's clean it up. We don't need D3 here anymore. So at this point we should get the data, and we can test it by going back into our, you see in our data, we get an error now because it's expecting the type to be historical price object, and we're tying it up to the types. So what we can do is we can just cast here, instead of casting it as historical price object, we can set our type here, and our value is going to be price, and we don't need the second one. So if we set our type, let's see if it yeah, you see it took the error out even though it's a different name. The historical price object array is price, and our types is just object with types. So because they're matching, ESLint recognized that, and it doesn't even throw us an error. So now go into histogram chart, and we can actually test it and see that the data gets here. So to test that, what we can do is we can just put a line breakpoint and debug our app to see that the data gets here. So I'm putting two breakpoints, one in the loaded, one in it's not loaded. I'm gonna add a configuration to my IDE, so it's gonna so we can debug it. So let's call it app, and the URL is gonna be http localhost 3000, and I'm gonna use Chrome. Okay, now let's debug it and see that we get the data. Sometimes when you run it, you have to run it twice because the first time it didn't done the debug. Okay, here we go. So you see, so the first time it's getting run, loaded is false, so the data didn't load. And then the second time, you see it got loaded. So you can go into the closure, props, and here's our data, 361. You can also debug it from the selector, but we can see that the data got in, and our code is much more cleaner now that we don't need to put the code to load the data, and we can share the data with other components. Like you saw, we need to share the data with that table that lists all the prices. Next is in our histogram chart, We want to start by setting up our helper. So open up histogram chart helper, and a few things we can clean up here. We're not using the y accessor, we're only using price, so we can delete that code. And in terms of our x scale and y scale, we can, let's clean up, we're going to change the domain. We don't need the nice, but we do need to change our domain. So for the domain, we need to create some kind of constant to handle the maximum price. So for our domain, we need to know what is the maximum price, and what we can do is we can use mat.max, and then here we can map through all of our data, and we can use our helper x accessor to kind of map it to our price and compare it with 0 and find the best results. And then to the best results, I'm going to add 75, the number 75. The reason that I'm adding a number at the end to offset it, because in the final result, if you remember, I had the price and I had the days is sitting on the ticker. So if I'm going to add to the maximum another 75, it's going to take my x-axis and make it a little bit bigger, and I can use that space to position a text label. Now instead of my x scale, I can use my domain using that maximum price we set. Now for the maximum price, I want to limit it to 75. So I could start it from 0, but based on the pricing, once you look at the chart, you can see it better. Then you can see that it's never the price of 0. So it's better to kind of to figure out where you want to limit it, and I just want to give it a specific value instead of calculate the minimum. That way, I'm defining my space better. But if I want to, I can also create a minimum price and just set it to the first price. But that's just a better way if you want to control the data. And this is a good example when we're working with histogram, that the data is not really, we don't care about one day, we care about a bunch of days together. Now for the Y scale, we really don't need to make any changes. It just needs to be the height, and the domain, we're going to set it in our code, because the domain is going to change based on the slider that we're going to set. So now we have the Histogram chart helper ready, and we can start working on our memorize update callback. But before we do that, we need to take a look at our JSX. So we have all the elements ready, and we can the element to draw the chart is going to be called chart group, and we have everything ready. We don't need to change the metrics. We can clean that up. Okay, so we're really going to start from here, from working on our chart. What we need to do before we draw the chart, we need to do all those calculations. So the first calculation I'm going to do is we're going to calculate all the beans. So to calculate the beans, histogram, D3 has a method called .bean, and that takes a value, and we can assign our data, and then it's going to map the data based on how we set it. So we can return our data price. Okay, if you want to cast it for TypeScript, just set it as unknown, because we don't know the type, and then we need to cast it as the data type. So as types data, that's going to give us a price, and we need to make sure it's coming as a number. All this mess is for TypeScript, just to make sure everything is correct. Or we could have just done here ts ignore if we don't want to go through this hustle. Then the next step is we want to set the threshold. So the threshold that it's expect is basically how many beans we want to set. So what we can do is we can calculate the number of bean based on our X scale. And to calculate it, it's going to look like this. We can call our S scale and use the X scale. And then we can, the X scale has a method. If you look at our X scale, we're using the scale linear, and the scale linear has a method called ticks. And if we pass the number of ticks, it's going to return, it's going to do all the calculation for us. So what we need to do is we need to create some kind of state to remember the number of ticks. That way we can change it. So what we'll do is we'll create a constant. Let's call it number of ticks. And we'll put a method so we can set it. If you remember, we had a slider there. And we're going to use state for that and set it, the initial one, to 10. And now I can take that number of ticks and pass it on to the threshold. So now we have the histogram calculation that we can utilize to create our beans. So now to create our beans, we can use our histogram, and all we need to do is we need to pass our data, and that TypeScript doesn't like it because it expects a different structure. So if you look at D3 docs, or you dig into the into the bean method, the histogram generator, it's expect a type as array, and we can pass as never. So that way we're converting it, we're casting it as an array, so our method doesn't throw ESLint errors. And now that we have our beans, we can use those beans to figure out the excess maximum values. So we can create a constant, and let's call it y, excess maximum values. It's going to be the max D3, the maximum beans based on the data of the length of our data. So we need to calculate the number of beans the maximum number of beans based on the data that we're passing. And now, if you remember, in our helper, we didn't set the domain. So if you look back in a histogram helper, we purposely, for the Y scale, didn't set a domain. The reason we didn't set a domain for the Y scale is that those days are going to change. So we want to change it on runtime instead of compile time. So the way we can do it is we can just call scales and call the Y scale, and then we can set our domain right here. And we can set the domain from 0 days all the way to the YX maximum values of days that's going to show. So that really is going to do a nice calculation for us of how many days the most, because each bean is going to represent days and we want to know how many, and that will do the trick. We work with scale, it's always expecting a number array, so we can pass that. So it's the first number and the second number, so we need to cast that as that. Looking good. Now we can start creating those bar nodes, those beans that create our bars. So let's call it bar node, and what we're going to do is we're going to attach them into our bounds. We're going to select our chart group. If you remember, it's already set for us in the JSX, and the JSX we have the chart group. So we need to set it, we want to attach those bars into our chart group. and then the next step is we want to select all the elements we're going to create once we enter. Once the bars enter the DOM, we want to select all those elements. So those elements are going to be a rectangle. Okay. And we want to set the data beans. And now once what I'll do this time is let's break out the chainings. This way it's split between setting up the data and what happened at the enter the DOM. So it's just easier to read, but it's not necessary to break the chaining. I'm just doing it this way so it's going to be easier for you to read. So once we enter, we can append a rectangle. And what we're going to do this time is we're going to merge. When we're going to merge our bar nodes, what's going to happen is going to do that nice transition for us. So once it's going to get the existing element, and then we can create our animation. So to create our animation, we need to call the transition, and in the transition we can set the duration of the animation, and I'm going to give it 750 milliseconds. Next, we need to set the transform. So what we can do for the transform, I'm usually using style, but really attribute is a better option because we don't need to use the pixel. So it's let's prune for mistakes, because many times if you don't set the transform correctly, it breaks silently, so it won't even give you an error. It's just not gonna position our chart correctly, and then if we don't see it correctly on the screen, we can go into really chasing a bug that it's going to be hard to figure it out. So it's better to really pay close attention when you create your translate method, and it's better to use the attribute over style when you can. And inside of our the top left corner, we need to calculate that. So we can use our scale methods to calculate all of that. Let's just put a placeholder for now. And when it's going to take the data through, it's going to create a bar node. So what we need to do is we need to go back to the widget, histogram chart widget, and in the type we need to create another type. This way TypeScript will know what to expect. So we'll create a type and we'll call it bars node. And the way it works, it goes through the data D3 and it creates 3 elements, x1, x0, x1, and a length. So what we can do is we can actually tell TypeScript already to expect those values. Okay, let me make sure it's not breaking. Okay, it's not breaking. Also in the widget, take a look here. I didn't set the property name. So the property name, we're only using price. So this gotta be set, otherwise it just won't draw anything on the screen. Now I'm back at the histogram chart component, and the histogram chart component, we can now use those values. For the top left corner, I can use the scales dot x scale and then pass the D as types bar nodes. Oops, types bar node, and we're going to use the x0 value. And then for the top corner, let's see what's, maybe it needs an unknown. Let me see. It expected as a number, so we need to close all of this statement in a bracket. This way it's going to return the x1 as the number. And then for the top corner, we're just going to use the length. Okay, and that's how we're going to translate it. Now the next thing we need to do is we need to set the width and height. So for width, so we need the width, we need the height, and we need the fill. So let's just set those elements: width, height, and fill. And those elements, it's really, we're better off putting it here because we need it after the transition. So let's put them here. So the color I'm going to use tomato for the fill, attribute fill, and then for the width and height we need to do also a little bit calculation using our X scales. Our width is going to be our bar node x1 minus x0 minus 1. So, and we're going to do that using really our scaled methods. So we can do the data, and inside we're going to return the scales x scale d x1 minus scales x scale d x0, and then from that we're going to reduce 1. So it's going to give us all this casting errors, so you just need to make sure we're casting it correctly. So it needs to be cast as types bar node, and the same for the D0. And then for the height, what we need to do, we need to take the bound height and reduce the calculation of the D length from the Y scale. So it's going to look like that. So we need to take the data, and in our inline method, we need to return the props dimension bounded height minus the Y scale calculation of the data length. So scales Y scale of the calculation of the data length. Okay, let's take a look. If you go and refresh, it looks like we got an error because we got 1 bar. And 9 times out of 10, when we have all those issues of the drawing of the chart, it's really usually that translate. You see, we got so much issues with it. Yeah, it looks like the top needs to be the Y scale, not the X scale. And at the end, I have an extra comma. So let's clean that. There you go. You can see really 9 times out of 10 when you got issues with the drawing of the chart, the positioning, the translate, is just fails silently, and it will just not position it right, and then it can take some time to figure out what's going on. So now we're able to draw the chart, and we're passing how many bars. You see 1, 2, 3, 4, 5, 6, 7, 8, 10. We can pass how many bars we want to, ticks we want to fill. So we got that set up. Then what we need to do is, after we creating our after it's drawing for us, we need to remove any extra bar because it's going to get redrawn. So when we exit, we need to remove any extra bars. Otherwise, when it's refreshing and drawing those beans, it's going to leave the old one in. So we need to make sure that the old beans are gone once we redrawn everything. And then the next thing for us is to create our peripherals for the y-axis. everything looking good. The one thing we want to do is, since we're expecting a transition, so the number of days is going to change, then we should really add a transition, and we can give it the same duration of 750, so it's going to take the same time for the chart and the y-axis to drawn. Then let's look at the x-axis. Our x-axis looking good, and we can go back and take a look. Okay, great. Now we need to update our dependencies. Now this is really important. If you don't put the number of ticks as part of your dependencies, once you make changes in the ticks, it's not going to call the use effect, and then you won't see the change, and it's going to be really tough to figure out why it's not changing the value. So you really have to make sure that the dependency correspond to whatever you're using inside of our use callback.